Okay, this is a lesson on factoring trinomials, specifically difference of squares. That's the name of the trinomial. The objective today, we're going to factor those kinds of trinomials, okay? And it's really easy, but you need to really focus right now because I need to show you something you've learned before and you know how to do it, and you'll see the pattern, and as soon as you see the pattern, you'll be able to do the opposite, okay? But if you don't pay attention right now, you're going to miss it, and this whole lesson, you're going to be lost, okay? So please focus. So a few weeks ago, before break, I taught you how to do this kind of problem. It was 3x plus 2 times 3x minus 2. Okay, so you're like, you've already showed this so many times, Mr. Rinkwitz. So we multiply, we got 3x times 3x is 9x squared. 3x times negative 2x, or negative 2 is negative 6x. Then we got 2 times 3x is positive 6x. And then 2 times negative 2 is negative 4, right? Now, do you notice that there's 3x and 3x? These are the same numbers, and these are the same numbers. Do y'all notice that? Yeah. Okay. And this is a plus, and this is a minus. What's 3x squared equal to? 9x squared, right? What's 2 squared equal to? 4, right? Okay. So I'm going to simplify this. What happens to my negative 6x and positive 6x? They cancel out, right? They go away. So really all I'm left with was 9x squared minus 4, right? Does that make sense? So all I really should have focused on was the first numbers and the last numbers. Remember this? This is called difference of squares, right? So today we're going to start with this 9x squared and go backwards. That's the point, okay? Are you tracking with me? Yeah. Yeah? Give me a thumbs up if you're tracking. Okay, good. Okay, so we're going backwards. I'll show you the steps. Super easy. Here are the steps. If you want to write them down, you should have them ready. It's even simpler than this, okay? So, number 1. So, to factor means to what? What is factor? To break apart, right? Or to split apart, right? So, number 1, we're going to look at here, x squared minus 4. So, I noticed that this has a perfect square, and then it has another perfect square. 2 perfect squares. So I think, what's the square root of 9x squared? Oh, that's 3x. What's the square root of 4? Oh, that's 2. And then I check, I look, and I'm like, oh, look at that. There is a subtraction sign there, right? So I'm going to assume this is a difference of squares problem now because of those 2 things. So I'm going to make 2 parentheses. And I ask myself, what's the square root of 9x squared? Square root of 9x squared is 3x, so I'm going to put 3x here and 3x here. Then I ask myself, what is the square root of 4? Well, the square root of 4 is 2, so I'm going to put 2 here and 2 here. Watch, last step. Everyone's watching. Don't write. I'll give you a chance to write. Pencil's done. After this, I just put a plus sign here and a minus sign here. I'm done. That's it. Okay? That's all you have to do. Again, all I did was I need to make sure there's 2 requirements. Listen, 2 requirements. Is this a perfect square? 9x squared? Yeah, because the square root of it is 3x. What's the square root of 4? Oh, it's 2. Good. These are both perfect squares. Second requirement is there a minus sign here? Yeah, so there is, so I could do this. If there was a plus sign up here, you were not able to do it. Okay, but since it's minus, it's okay. That's it. Super easy, right? Let me do one more for you. Well, if you did, I'll show you that later in the lesson. Okay, you can't use it. We'll look at it as an Xbox later, because you could do this as an Xbox problem too. Okay, number 2, first requirement. Do I have perfect squares? I ask myself, yeah, this is 49n squared. I know the square root of 49n squared is 7n. And the square root of 144 is 12. The second requirement I ask myself is there a minus sign? Yep, we're good. So we're going to make 2 parentheses. Square root of 49n squared is 7n, so I put 7n here and here. Square root of 144 is 12. Put a plus and a minus sign. I'm done. That's it. Right? It's pretty simple, right? The hard thing is that you have to recognize the pattern. As soon as you get that, it's good. So why did I teach you this? Well, the purpose of this is so that you save time. Raise your hand if you want to save time doing homework, right? I do too, right? I don't like working harder than I need to. So that's it. So why don't you turn to your neighbor before you start copying and tell them, each person take a turn taking one problem. Tell them the steps, meaning what are the requirements. There's 2 requirements. The first one is the square roots, and the second one is a minus sign, okay? And let's have you talk. Ready, set, go. Okay, so that was number 3. Number 4. Number 4. Again, turn to your neighbor just to get warmed up. Do we have perfect squares? Tell them. The computer's slow. Shh. Okay, do we have perfect squares? Tell your neighbor, yes or no? Yes. And tell your neighbor, do we have a minus sign? Yes, we do. Okay. Okay, so I want to see your answers up in 15 seconds. Okay. Okay. 30, 29, 28, 26, 25, 22, 19, 17, 15, 13, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. Answers up? Okay, good. Good. So, in case you're not getting it, they're both perfect squares. Square root of the first term is 11k. Square root of the second term is 6. So, it's going to be putting 6 and 11k here, plus and a minus sign. Okay, now, look up here, please. Let's look back on number 3. Okay, why does this work? Let's go back to our X box. Let's think about, look at number 3. What's A for number 3? A is what? 9. B is? Is there a B?
It's a B squared.
It's a 0. There's no B, so we put 0. Good, it's 0, because there's no B. What about C? What's C?
25.
25, good. Okay, so watch me do an X box, okay? Don't know how to do it? Yep. And it's negative 25. So I'm figuring out what my things that add up to. No, I'm just showing you why does this work, okay? So I'm doing the X box, and since I know my numbers, I know positive 15 times negative 15 is equal to negative 225, and it adds up to B, which is 0. So if I were to put positive 15 and negative 15, okay, I'm doing my fractions. They could be reduced, so it's 3 over 5 and 3 over negative 5. Right? Aren't they the same answers here? Yes or no? Yeah, they are, right? So that's why it works, okay? So would you rather do it the new way I taught you today, or would you rather do Xbox?
The new way.
Right? Why would we want to do that?
It's easier and
Good.
faster.
Good, it's faster. Just on this, can we do differences for us on all problems?
No.
They have to have the 2 things. What's the first thing? Negative sign. And then the second thing? Negative sign, okay? So should they have a B? No. B should be missing, right? Okay, so that's the only time you can use a shortcut, okay? Are you allowed to use Xbox? Yeah. You can use Xbox. So you could have done Xbox on this problem. Yes. You could have, yep. So if you don't like what I taught you today, that's okay. You can do it this way. If you like doing it this way, that's fine. I just think it takes longer, okay? Now, let's look at number 5. Okay, back to number 5. Ready? By yourselves. Ready, set, go. I'll give you 20 seconds. Okay. Again, why can't you do it? Why can't we do it, everyone? Hey, listen up. Shh. Raise your hand if you made the mistake. You just did it quickly. Okay, you're a bunch of smart kids because you're like, I know this is so fast. But what did we forget? What needed to be there? Plus sign. So, listen up. Focus. Whenever you have a plus sign, you need to, and you think, and there's no B, and there's a plus sign in the middle, even though these are perfect squares, there's a plus sign, and this is no good because there's no B, and if you were to do an X box, you want to be able to factor. Remember how yesterday there was non-factorable ones? So if we know A is 9 and B is 16, right? 0. B is 0 and C is 16. Well, we want to ask ourselves what is going to equal to 144 and adds up to be 0, right? So I set my X box up. And what times what is equal to 144? Well, I know that 1 times 144 and 2 times 72. And I keep making a list, 12 times 12, right? Now, which one of these is going to add up to be 0? What if they were all negative? Would they still add up to be 0? No. So is it even possible to factor this? No. So then whenever you see something that should be difference of squares, but there's a plus sign, you have to think the answer is not factorable. Okay, not factorable. So that's your answer. So what's your answer again? Okay, so tell your neighbor, why is this not factorable? Really quick. Ready, set, go. Okay, good. Number 6, by yourselves. Ready, set, go. No, by yourselves on your whiteboards. I'll give you 10 seconds because... Ready? Go. 10 seconds. Put your answers on your whiteboards. Ready, set, go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Answers up. Okay, you have to put non-factorable. You can't just put blank or no or negatory. None of that, okay? Sorry. Not factorable.
Can we just put like NF for not factorable?
No.
You have to write it.
You have to write it. If you don't write it, it's wrong, okay? Okay, so what I'd like you to do, please clean up, and I want you to pass your boards up and talk about these 3 questions. Ready, set, go. Your